Okay, for 3.4, you were looking at the volume and capacity of spheres, cones, and pyramids. So I have gone through the notes and pulled out the main information from each question just to allow this to go a little quicker and for you to not have to wait for me to write down formulas and all of that stuff. However, the first part that this starts with is making sure that you know how to go from centimeters to meters and meters to centimeters. To be able to do this, you need to know the ratio for standard centimeters to meters, centimeters cubed to meters cubed, and centimeters squared to meters squared, and then centimeters cubed to meters cubed. When we are looking at that, since 100 centimeters is equal to 1 meter, we need to square both of those numbers to get centimeters squared, and we need to cube both those original numbers to get centimeters cubed to meters cubed. So note it is not simply just add the cube and stick with the same numbers. Okay, when you are deciding which way to put it, arrange the ratio with the units you want on top and the units that you have on the bottom. So if you have centimeters cubed, you will be multiplying by 1 meter cubed by 1 million centimeters cubed. Okay, so you need to set it up so that these cancel out and you have one on the top and one on the bottom. Okay, as we're going through, I've pulled out and already written out the formulas. So this is the formula for a sphere. So, and I have also pulled out the key information. So a spherical exercise ball has a diameter of 1.2. I know my radius is half of my diameter, so I have a radius of 0.6. I can plug in what I have. Volume of the sphere is 4 divided by 3 times pi times 0.6 cubed. If you plug that into your calculator, you use 0.6 to the power of 3 times pi times 4 divided by 3, and you get a total of 0.9048 meters cubed. Except you don't want just the volume, you also want the capacity. So if we remember from our previous unit, 1,000 liters is equal to 1 meter cubed. So we times by 1,000 liters over 1 meter cubed and get 904.78 liters. Okay, so notice this would be your volume and this would be your capacity. Okay, next one, find just the volume of a sphere with a radius of 8.5 centimeters. That's pretty easy. We're given the main information we need. So 4 over 3 times pi times 8.5 cubed. When you plug that into your calculator, 8.5 to the power of 3 times pi times 4 divided by 3, you get 2,572.44 centimeters cubed. Okay, so that is your final answer. Next one. Oh, this one's a little more complicated. A sphere with a radius of 46. Okay, so that's volume. I chose to represent that one with volume 1, and it has a radius of 46. Is centered inside a sphere with a radius, so volume 2, and a radius of 76. Calculate the volume and capacity of the space between the two shapes, which means I'm going to be doing volume 1 minus volume 2 to just account for what's in between. So if I go through and do the calculations for each of those separately, I am doing 4 over 3 pi times 46 cubed, which gets me the large number of 40720.08. And then I do that with my 76, which will get me an even larger number. That gets me 1,838,778.369. And to figure out the difference, one minus the other. So 1,838,778.369 minus 4,077,20.08 gets you a total difference of 143,1058.29 for your volume of centimeters cubed. And then to go from volume to capacity, times 1 liter over 1,000 centimeters, and you end up with a capacity of 1,431.06 liters. So note once again, this would be your volume, this would be your capacity. Okay. Next, we are on to pyramids. So the generic formula for pyramids is 1 over 3, or 1 divided by 3, times the area of the base. So it depends on what the shape of the base is, times the height. So when you're dealing with a rectangular pyramid, your volume is equal to 1/3 of the length times width times height. So let's do a couple examples with those. So calculate the volume and capacity of a pyramid with a base that's 18 by 15 and a height of 25. So 18, 15, 25. So volume is equal to 1 over 3 times 18, 15, 25. Multiply those out and you get 2,250 centimeters cubed times 1 liter over 1,000 centimeters cubed, and you get 2.25 liters. Okay. Volume, capacity. Okay. Moving on. Now with these ones, we are just given the simple measurements for the pyramid and for the base. And then we just have to calculate out the volume for each of them. So we note first that make sure our units are the same. We got inches, 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 that's okay. So then we plug in what we have. And you end up with a volume of 1,615 inches cubed. Okay, next you do your next one. Length, width, height. (40 feet cubed) to make sure you have your units in there. Okay. Now we're dealing with a combination of two rectangular pyramids with the same base. So the length is 9.8, width is 4.3. So I've split them and written them twice so that I have them separated. And then one is a height of 6.2 and one is a height of 4.8. So equals 1 over 3 and this one will give you a volume of 87.089. Now this one gives you a volume of 67.424. V1 plus V2 gets you your total. So then you have your final answer. Now you are looking at the comparison between the prism versus pyramid as far as volumes go. Okay, so we will calculate them out. When you're talking about the volume between a pyramid and a prism, note that the volume of a pyramid is equal to 1/3 the volume of a prism. Okay. I'm going to keep moving on. Next, we have calculate the volume of each of the following pyramids, but we're given, this is a little different. We're given the slant height, but if we go back up, we don't want the slant height. We want the height of the pyramid. So which means we need to solve for it using our Pythagorean theorem like we have in previous units. So we have 17.5 squared, h squared, 25 squared. So if we isolate our variables, we end up with h squared is equal to 318.75. Therefore, h, when we square root our number, is 17.85. We can take that value and plug it into our formula. 1/3 length, width, height. 1/3, 35, 35, 17.85. We end up with 7,288.75 millimeters cubed. Okay. Next one's, we're given the slant height again. Well, guess we got to do those calculations again. Oops. Okay. So if we isolate our variables, h squared is equal to 228.75. Therefore, h is equal to 15.12. We solve for our volume. There you go. Now this one's even a little different again, because notice we have inches, feet. So what I have done is I have converted my feet to inches so that we are good to go and can keep operating and solving these questions. There we go. One thing I would suggest is making sure that you are solving these questions as you go along and not just copying it out so that when it gets time to do your questions, you know how to solve them. Okay, the next shape you are working with is working with the volume and capacity of cones. Okay, so remember cones have a circular base and then have a pyramidal top. So note carefully that you need H, which is this one, and you may be given S, so you need to solve for it using the Pythagorean theorem. Okay, we're going to do a couple examples with this one. So if a paper cup in the shape of a cone has a radius of 3.2 and a height of 6, how much water can it hold? Well, 1/3 times pi times 3.2 squared times 6. That gets you 64.34 centimeters cubed, which if we translate into milliliters, it's actually 1 centimeter cubed is 1 milliliter, since 1,000 milliliters is a liter and 1,000 centimeters cubed is a liter as well. So it will hold 64.34 milliliters. So calculate the volume of the following figures. You are given the radius and the height. Okay. Remember, apostrophe is feet, quotation mark is inches. Oh, now we have two different ones. The radius is the same, but the heights are different. Let's see how that changes. There we go. So given that the one height is 6 centimeters taller, it makes a difference of quite a lot. The importance of accurate measuring. Now we are looking at cone versus cylinder. Note they are not the same height while they are the same radius. Pi radius squared times height, 56.55 meters cubed. Pi radius squared times height. Okay, note the large difference, even though these were only one off. Okay, the volume of a cylinder holds a lot more than the volume of a cone. Okay, last page, we are dealing with cones. Okay, so, now we're given the volume, though, when we need to solve for the height. Well, let's plug in what we have in our equation and isolate it and solve it out. So we know our volume is 4,071.5. We know our radius is 12. We don't know our h. Since we only have one unknown in the equation, we can solve it. I'm going to solve it out in steps using my BEDMAS. So I have done my exponents. There was nothing in brackets to solve. Now I'm going to do out my multiplication of 1 over 3 times pi times 144. And I end up with h is equal to 27. Make sure you can rearrange an equation. It's a very important skill to have. Last problem. A cone has a slant height of 15 centimeters and a radius of 8 centimeters. Determine its volume. Well, this is where the Pythagorean theorem comes in handy. We have 15 squared equals h squared plus 8 squared. If we solve that out, 15 squared minus 8 squared, and then square root that answer, we get h is equal to 12.69 centimeters. We can then plug that into our equation. And we get a total volume of 850.49 centimeters cubed. There you go. Not too bad. Not much different than a previous unit or previous section. So now you're trying to practice your skills on 192 to 193, numbers 1 to 5.